All right, let's continue. We need to find, we found domain whole situation. Now let's talk about the horizontal asymptotes. The degree of the numerator is in this case, is 2. The degree of the denominator is also 2. So it does have a horizontal asymptote, and it's at y is equal to the ratio of the leading coefficient. The leading coefficient here is 3. The leading coefficient here is, if you multiply x squared is a 1, so y equals to 3 is the equation of the horizontal asymptote. A graph will either have a horizontal asymptote or an oblique or none at all. It won't have more than one like vertical. So if it has a horizontal, then it doesn't have an oblique. None. Okay. So let's go through and just decide about our horizontal asymptotes for this. Number 2, degree of the numerator. N is 1. M is 2. N is less than M, so there is a horizontal asymptote. Y is 0. There is no oblique. Number 3, N is 2. M is 2. Or even this case, reduce N is 1. M is 1. They're the same degree, so Y equals to 1 over 1 is the horizontal asymptote. There is no oblique. All right, I erased 4 for more room. The degree of the numerator is 2. The degree of the denominator is 1. Oh, okay. So that is no, none. Is there an oblique? Yes. Yes. Okay, to be continued. We're going to come back and do this one. All right. Degree of the numerator, 3. Degree of the denominator, 2. Okay. There's no horizontal because the degree of the numerator is higher, but it's 1 higher, so there is an oblique. So there's no horizontal, none. Oblique, yes. Okay, to be continued. We'll deal with these 2 last. Let's take care of 1, 2, and 3 now, okay? All right, what is next? I have on there, does the horizontal asymptote cross the graph? This is how you figure it out. You just set f of x equal to the horizontal asymptote. So, does it cross? This is our question. Does it cross? Cross? We'll say 3x squared over x. Actually, that's x squared minus 9. Let me just leave it in that form. X squared minus 9. Take f of x and set it equal to the horizontal asymptote, 3 over 1. And you can cross multiply here. 3x times 1 is 3x squared. 3 times x squared minus 9 is 3x squared minus 27. We solved this equation for x. So I'm going to subtract 3x squared from both sides, and I'll get 0 is negative 27, which is a contradiction. This is telling me, no, they do not cross. Cross? No, it doesn't cross. It's horizontal. Okay, how about here? Does this cross? We're going to do the same thing. Take your function, set it equal to the horizontal asymptote, which is 0. 2x plus 3. X squared minus x minus 20. Does it equal to 0 over 1? 0 times this, if I cross multiply, is a 0. 2x plus 3 times 1. Solve for x. Yes, it crosses. Yes. Where? When x is negative 3 halves, it's going to cross, and the y value is going to be, the y value is going to be 0. This is the point it crosses at, okay? How about here? Is this one going to cross? I don't know. Take your function, and we can use the reduce function, x plus 1, and set it equal to your horizontal asymptote, which is 1. Cross multiply. X equals to x plus 1. Subtract x from both sides, and 0 equals to 1. Oops. That is not true. So, does it cross? No, it does not. Okay, we're going to deal with these 2 at the end. So that took care of the cross situation. We expect that to cross. How do you find x-intercepts? A fraction will only, you set y equal to 0 and solve for x. Set f of x equal to 0, solve for x. When will a rational function or fraction equal 0? Only when the numerator is 0. So, to find x-intercepts, set your numerator equal to 0. So let's do that. Set 3x squared equal to 0. Solve for x. Divide by 3. Take the square root when x is 0. When x is 0, y is 0. So x-intercept is when x is 0, y is 0. All right, what about our y-intercept? How do you find the y-intercept? Well, you take f of 0. Instead, you let x be 0, solve for y. So, for let x be 0 and solve for y, we're going to get 3 times 0 squared, or a big 0, over 0 squared minus 9, negative 9, which is 0. So the y-intercept is when x is 0, y is 0. We got the same point. You will always find that. The origin is an intersection of the x and y axes. So if you have 0, 0 as an intercept for the x, it will show up again for the y. So those are our intercepts for that one. Let's go here and find our x and y intercepts. X-intercept, set the function equal to 0, set the numerator equal to 0, and solve. 2x plus 3 is 0. 2x is negative 3. X is negative 3 halves. Oh, we already found that point because that's where it crosses its horizontal asymptote. That's its x-intercept. What about the y-intercept? Well, take g of 0. Let 0 be there. So that 0 plus 3 is 3. 0 minus 5 is negative 5. 0 plus 4, negative 5 times 4, 3 over negative 20. So this means when x is 0, y is negative 3 over 20. That's the y-intercept, okay? X and y-intercepts for this guy. Set the numerator equal to 0. When is this going to happen when x is 0? What will y be? Y will be 0. Here we're going to get the same y-intercept, right? If you say m of 0 to find the y, we'll get the origin 0 over 0. It's the same. All right, so we'll deal with these two at the end. Let's go ahead. We have basically everything we need to start graphing. Let's graph. I'm going to make some room. I said it didn't cross. Okay, so got some room for this guy. Okay. Need some room for this guy. Okay. Need some room for this guy. Now, you are allowed to use your graphing calculator. I used my graphing calculator to fill in my graph, but I'm going to want to see details on your graph. And what I demonstrate is what I expect from you guys as far as what you give to me. So right here, we're going to graph this guy. You should graph it. You should begin. You've got your x, y axis, right? Begin by labeling any points that you know about and any asymptotes that you know about. So, what I know is that there is 1 point, 0, 0 on this guy. And I know there's a horizontal asymptote at y is 3, so I'm going to go up here. 1, 2, 3, and I'm going to dash him out. Y is 3. I'm going to label him. I have a vertical asymptote at x is 3 and x is negative 3. So we're going to go over here to 1, 2, x is 3. X is 3. And I'm going to go over here to negative 1, negative 2, x is negative 3. X is negative 3. Now, does it cross its horizontal asymptote? No. Okay, that's good to know. And we have everything accounted for. Now, I just put it in my calculator, and I said, how will this guy graph? And I made sure it looked reasonable, and it did. If it didn't look reasonable, what I knew is maybe I had typed it in wrong. This is what my graph will look like. So, it hugs its asymptotes. It hugs its asymptotes. All right. This is the graph for number 1. Now, I will want to see all of these things labeled, this point that it passes through, and all of this information. So be prepared to list that in detail. I really can tell when people don't know what they're doing and they just copy a calculator screen. So don't do that. All right, number 2, let's graph this guy. Let's see, this is number 1. Okay, number 2, let's graph him. Right here. What do we know about him? He's got a vertical asymptote at x is 5 and x is negative 4. So 1, 2, 3, 4, 5. Dash him out. 1, 2, 3, 4. Dash him out. This is x is negative 4. This is x is 5. It's got a horizontal asymptote right here. at y is 0. Okay, so even if you can't dash him out, label him y is 0. So we check here. It does. No holes, no oblique. Does it cross? Yeah, it crosses at -3/2, 0. So this is about -3/2. So there's the point I want to make sure that I highlight. Okay. Where's the x-intercept? Right here. Where's the y-intercept? 0, -320. So this is going to be close to there. So just kind of mark that point in. Then you are allowed to use your calculator to see, but you got to make sure that you show me where it passes through. So it passes through here. Good. And then it's going to hug here. And then it's going to hug here. Good. That's number 2. Number 3. Alrighty, what have we got here? 0, 0. Does it cross? No. Is there oblique? No. Is there horizontal? Y is 1. Yep. Y is 1. Is there a vertical asymptote? X is -1. X is -1 is my vertical. Okay. Oh, and there's a hole I got to remember to put in at the end. Okay, so what you do is you go ahead and graph it. And it will hug this. And how do you know how to graph it? If you don't have a graphing calculator, it's okay. It's nice if you do. It makes it real quick and easy. But if you don't, what you do is you plug in points. The olden days, that's what I did. That's what they said. Oh, you pick some values. And so how you would choose which values to pick, like what if your batteries die on your test? And you're like, I don't have time to go buy batteries. What do I do? You plug in X values and you calculate. So you say, okay, what is going to happen at X is -3, -2, at X is -1, at X is 1, 2, and you get values over here, and you put points in, and you plot points, and you connect the dots. That's how you would do it. But if you do have your calculator, that's great. Go ahead and use it. It's going to look like this. Do not forget the hole. When X is at 1, 2, 3, you're going to go up here, and you're going to make a little hole right there. And that is the completed graph for number 3. And we already did number 4. And so I'm going to erase this so we have room for 5 and 6 for our last part.